Hi, I'm Adam with Similie. Today I'm going to do a video about how we assemble our Hyphen elemental boards. So a little background about me and about Similie is that we've been building software and hardware solutions for countries such as Timor-Leste for almost a decade now. And for those of you who don't know where Timor is, it's a small island country just above Australia. It's pretty well known within the region, but in the global community, it's something that most people may not be aware of. But ultimately, it's a country that's pretty out of the way from normal distribution channels, and it's challenging to bring in hardware and other kind of solutions there to solve some of the challenges that we face. And so Similie is a company that attempts to build solutions that help solve some of those challenges. And so when we build our solutions, we're trying to find hardware and kind of materials that you can find on AliExpress or on Amazon, those sorts of locations that are easy to kind of ship to our location and allow us to build out solutions that have impact. And so today I'm showing you our Hyphen elemental line. And when it comes to the word, our brand Hyphen, ultimately this brand here is the hardware side of our solutions, and the elemental series is the side in which we have open source solutions around. And today I'm showing you the hardware. This is our 12-volt battery, solar powered battery controller. And then we've got our breakout that works off of this device. And ultimately what we do is we fashion these in a way in which we can deploy them out in the field, connect them to various sensors, and begin to take reads in the environment. It allows us to know if there's risks around flooding or other weather-related risks. In addition to that, it also allows us to kind of interact in typical IoT sense with the world around us, such as activating pumps should we detect danger, or switches and so forth. So ultimately, our effort is really to try to package these, build them in a way in which we're able to deploy them out in a solar-only environment. Getting commercial power is often quite limited for us, and do it in a way in which it has always-on access. Our primary product that we use these for is our early warning systems. And because of that, we need them active 24 hours a day. And so we've got a pretty go big or go home mentality when it comes to power and making sure that the solutions are always active. And so this is an example of our 12-volt solution that allows us constant 24-hour access, where we're getting telemetry at least once every minute. In addition to that, we're able to communicate with our software platforms to our devices with the software that we've written for it. That software is an open source repository. We've got our Hyphen Connect, which allows you to connect your ESP32 based devices to an MQTT server and communicate with those devices. And then coming soon, we'll have the actual OS version of that runs our main applications. But today we're going to focus on our 12-volt power battery and the breakout and its assembly, and to show you some of the things that we do with it. And so you can see here we've got an example of a two battery solution and a breakout that we've pieced together. It's without the microcontroller here. But ultimately, this is how we often package them. This thing sticking out here is a little antenna, a 4G antenna that we have outside. You can see a power button, and we've got our solar connector and a couple of outputs for I/O to our sensors. So this is more of a finished product, but we'll walk through some of the gotchas that we encounter when we're working on solutions, when we're trying to piece these items together. And we'll talk about some of the tools and what it is that how you can and take the schematics for our Hyphen line of products, get them made yourself, and what tools you'll need in order to piece those together. We do offer these solutions on our website, and it's often cheaper just to get it through us. But we really want to feed back into the community of innovators and make sure that those innovators out there, they've got a leg up on some of the ideas we've been doing for a number of years, and it gives them an opportunity to help us iterate these solutions and make more better and more impactful solutions. So here's an example of our 12-volt battery system in which we just got fresh from JLC PCB. We took the schematics and we were able to get all the parts and everything placed on top of the circuit board and so forth. So it comes finished and ready to go. Really all it needs is kind of some of the finishing touches that we have here in order to get it operational. In this pin, we have a basic switch scenario. It's a fairly simple solution where you touch those two connectors there, and it's going to send the current it needs in order to activate the 5-volt output. So this is a 12-volt power supply, but it's producing a 5-volt output that we use for our sensors and microcontrollers and so forth. Here we've got a solar in. So with this, we can connect solar panels that go up to 35 volts. Generally, we say around 2 to 3 amps is max, but really for most of our use cases, we're using 10 to 20 watt solar panels, generally producing around 18 to 20 volts, and for always on activity on a 12-volt battery system, this seems to work quite well. And then here you've got the typical ground and power, but you've also got I2C connections, so that way we can read the values off of the battery sensors. Here we've got the breakout that we've created, and so we generally have it to where you can connect our output from the battery into this JST header pin. You can see we've included a SD card reader. This allows us to store offline payloads and so forth, reset switch and so forth. We've also in this one, we've included a watchdog circuit. And so the online or the open source repository does include a watchdog circuit. Plus it will include an accelerometer. This particular board doesn't have the accelerometer on it. And so we can kind of piece together different solutions based on what the application is. But with the watchdog, you need to make sure that if you were to use something like this, you've got a dog pin here, number 32, where you need to pull that up every few seconds in software. Otherwise, it's going to reset the microcontroller. So when you're writing software for these things, you got to make sure you pet the dog. Otherwise it does switch off. And we do that because we want to make sure that there is any kind of lockups or failures out in the field. There's hardware, dedicated hardware for managing that. What you see here are the microcontrollers that we use. We get these on AliExpress from a company called LilyGo. They're ESP32 based microcontrollers here, or packages here. Really kind of elegant, low-cost solutions. Ultimately, it's got the PCI Express output here. It's really PCI Express to serial and other kind of pins and so forth on it. But ultimately we got this output here that allows us to kind of expand and add different radios to it. And so you see here you've got your typical ESP32 rover with Bluetooth and Wi-Fi. For some applications where Wi-Fi is accessible, we leverage these. This allows us to leverage some really low cost solutions. But ultimately, we have it to where for most applications, we're going to leverage these radio controllers here that connect into the 2G, 3G, and 4G networks. You can see here we've got the SIM tray here as well, and the various pins and so forth. When these come from LilyGo directly, they'll generally come in a package with these pin headers, but they're not connected. And so we solder these on, and generally we do it upside down, so that way we can have it to where we fit our radios on them, and then that's how we socket that into our breakout board here. And so these kind of items here, they're just part of the board. We don't really leverage these in our designs, but certainly those that want a kind of auxiliary power could do that. Little holes here that are poking out for antennas to string through, and then we also have enough space to where with a little bit of and tape or other kind of solutions, electrical tape, we'll place these down here and strap them down so that way you have GPS radios as well. So some of the parts that we use are just JST 4-pin headers. You can get these on AliExpress. You can get them Amazon, other kind of big retailers offer these. Note that they always come, often unless you have a pretty consistent supplier, they often come with different kind of pinouts here, and so often we have to go through and we have to swap them out and make the connections correct for our applications, which I'll show later. And then we also use these just simple power and ground connectors. When it comes to the switch, all we need to do is connect these two to get it active. So it doesn't matter what the polarity is there, but on the solar controller you will see a plus minus. So if your connections are not correct, like we've got here, I'll show later how we go through and swap those. This board does include a reverse polarity indicator, so if you were to plug that in incorrectly, it's not going to blow the board. It'll be protected and it will warn you that it's happening. Generally we use 2 of these, and so the other one would be for our I/O, 2 or more, depending on what our output is. And so in this case, for most of our deployments, we're going to be leveraging this for our all-weather systems, and so we plug it, and that runs on SDI-12, which this pinout is designed for. And so we connect that and we pin it up with various output options. And so in this case, we've got a 4-pin, a smaller 4-pin. I think this is a 12 mil. And then for most of the commercial applications that we offer, we use a 16 mil. In this case, we've got an 8-pin connector, but most of the scenarios that we work with is generally on 4-pin. So if we were to send out an 8-pin, generally it's to be compatible with various breakout boards that we offer. But for your application, you can use any kind of output or connectivity that you want. It just depends on your use case and scenario. We've had really good luck out in the fields with these aviator connectors. We had it in the past, in older designs, we used, such as in this example, we were using Cat 5 and Cat 6. which we made that decision because we could find it where we are. We can find it easily in Timor. It's shockingly difficult to find just 4-pin connect or 4-pin or 4-cable wires in a market like that. And it's particularly some that are robust and durable for UV protection and outdoor use. And so it was easy for us to find Cat5. One of the challenges with that was that it was quite brittle in some of the harsh environments that these were deployed in, and the signaling would break down quite readily, and so that kind of forced us to evolve and switch into different options, and so that's why we've moved to mostly to these aviation plugs, but we also have certain deployments where we're using 3.5 millimeter jack, and that's what this header here is for. And so we can leverage that and connect this cable here that goes into an external breakout that supports those 3.5 millimeter heads. So this is an example of the solar end that we use. It's largely overkill for those kind of solar panels, but we found that these CN Linko, however you pronounce it, solutions are quite good. We generally have it to where when we set these up, we make sure that we've got our ground at the top and our plus at the bottom, and so when we wire our connector, we make sure it's accordingly set. But that's more of a tradition that we have at Similie. It's there's no engineering requirement there. A part of your kit, you should definitely have some of these insulators here. They heat shrink. You heat them up and they'll wrap around, and it's good to have these in order to make sure that anything that's existing out in the field for years on end, this really helps to make sure that one, they're protected, and two, that they stand the test of time. And so when we piece these together, you can see here we've got an example of a box that we might order. This one here is, I believe it's 190 centimeters or millimeters by 60. And so these are pretty standard. You can find on, again, AliExpress, Amazon. There's versions in white, there's versions in black. And so you can find these pretty much anywhere where there are major retailers and or online retailers, and we do the drilling and so forth. What you saw here is an example of how we'll drill this box in order to support the I/O that we've got. In this case, we're using two of these smaller ones because we're trying to leverage more additional hardware that the standard one output might not support. In addition to that, we generally kind of slap on one of our labels, and everything is ready to go once assembled. And so the next phases, I'll go ahead and kind of show you a few tricks around how we work with some of these parts. Generally, I get a kit like the iFixit here. This is really quite perfect and has almost everything that we need in order to piece our solutions together. But in terms of other kind of tools that we might have, you might have your needle nose. In this example, we have it to where our parts, the PCB manufacturer keeps these guide rails on there for manufacturing, and so you can use these kind of pop off on the side, a good set of needle nose is always really quite useful. Notice the screw holes here. These screw holes are aligned with our ESP32 based breakouts. We have other kind of legacy products that we use the holes for. In addition to that, the holes generally without any of the grounding, those are going to be holes that we use to screw down into our boxes here. So I mentioned before that we have one of these power cables here that we've got reverse polarity, and so generally to fix that, I just take set of tweezers here, and we just go through and swap them. Obviously, if you've got a stable manufacturer, you can buy these. Pre-done, and when it comes to us selling these commercially, we generally have those. But if you were out in the field and trying to build these out wherever you are, it's you get it to where it doesn't come exactly the way you want it. It's pretty easy to correct. Generally, just get something small in there, get it pushed down, and eventually you'll get into where they'll slip out. Sometimes by doing that, you're going to weaken, or you're going to compress a little hook that you've got here at the top. And generally after do it, I just kind of pop it out, and that allows it to fit nicely back inside. Sometimes you can have it to where you strip it, and if that's the case, you're really just going to want to start again, just get another one. Buy these in bulk, and also make sure you've got it to where as we go through, I'm talking and not really paying attention. But you can see, you may not be able to see on the camera, but there is a minus and plus, and we just need to make sure that we're getting things lined up appropriately. So our minus is on this side, yep, and our plus is on this side. And after you do that, you want to give it a nice tug, make sure you got it in there correctly, and you should be good to go. Now, I have to do the same thing for these, because again, these just came in a sorted pack, and we often have to swap these out. And so in this case, we've got it to where you can see on our breakout, our plus is now minus, and our minus is plus, and we've got these swapped around. The way we generally look at it is it's in the right kind of color order. It's just it's inverted from what we normally set it up, and so generally I like to think of it as like black and yellow, if that is the color set that they're using. Bumblebee, so it's like a bee color, and we see white and red that we kind of use. Timor's closest neighbor, Indonesia, as the color of their flag, and so bumblebee in Indonesia is what we want, but in this case we want it to be to where that's inverted, to where our black and our red are swapped in this orientation. And so I'm going to swap these out now, and you need it for both as well. So I'm going to swap these around now. In the actual footage, I will speed this process up because doing this it can take forever. Okay, so now we've got it to where these are switched around. So we've got the correct polarity here. We've done our bumblebee and our Indonesia. And so we've got it to where plus and minus line up from where the board says. And likewise, when we were to go down to the battery portion, we have it to where everything should line up as it's supposed to. The same orientation that we see there, we'll see on here. And so you've got ground on the far left, and you've got our positive on the far right, and you've got the SCL and SDA interfaces in between. SDA would be your or SEL rather, is going to be your yellow interface there, your yellow pin. And so now we've got it to where we're ready to do the wiring and so forth. It's just a matter of fitting everything back together and putting everything in the box. Part of that effort is making sure that you get your batteries charged up before you bring it out in the field. And so I've got this charger here where we can put in our chargeable batteries, and we can make sure that the batteries are close enough in terms of their voltage output and so forth, to where we don't have some massive differences between the various batteries. In this case, it looks like both these two are full, and we're just waiting on one for a few minutes to finish its charge, and it should be fully ready and ready to go out to the field. So one thing I didn't mention before is that when we stack these, we generally use here. I've got some plastic risers. I don't think these are quite large enough for this application, but I've got some other ones here lying around somewhere that I'll go try to find here in a moment. But ultimately, we use these risers. In our more commercial applications, we generally use brass risers. These plastic ones are good for scenarios where you just want to test your configurations and so forth. But out in the field, we use our brass risers. You could on some of these holes here, we've got it to where there are these are grounding holes, and so by using brass, we get a good solid grounding between the various levels here. And so that's partly why we're pretty focused on brass, but it also allows for better shippability and a lot more robust deployments when we use them. When we place these together, generally what I like to do is make sure that we can, they do have it to where you can use like a plastic screw or a screw top, but generally I just take another riser and use that in order to place down the IO shield. This allows us, when we're out in the field for maintenance purposes, we can easily kind of lift this here. So now we're going to go ahead and screw in our connector, or our wires to our connector to the battery. You want to do this first before you place it in any of your boxes. Generally, you kind of bring it down, and then you let the wire hook, and you kind of slowly tighten it. I then often hold it and get a good strong tight. You don't want to go too tight, because eventually you'll have it to where these breakouts they'll snap and you won't get your wires in or out again. But you want to get it nice and tight, because these things are often going out into the field, and with expansion and contraction through the day, that they can have an impact. So you want to get them good and tight. And you want to use a gauge of wire that's also appropriate. Some of the gauges, some of the wire that you might find for these, there'll be a pretty small gauge, and so a little bit cheaper than what I've got here. But having a good solid gauge and getting them good and tight is how you can have the best longevity when out in the field. And in this case, I place it into the receptacle, and didn't catch it. Put it up underneath, and it slipped out. So you got to make sure that you're testing each one, making sure they're good and tight. If they were to slip out, I can guarantee you that your deployments are going to have trouble. Generally, in order to take care of some of the slack, if your cable's too long, we'll just do a simple tie like this. Just keeps it out of the way, makes it to where we can easily tuck it in underneath for any of our deployments. So the next phases are going to be to add the risers, and for that I'm going to go find a longer set. So a common challenge within these sorts of engineering contexts, particularly when you're trying to develop engineering solutions in resource limited locations, is supply and parts. And so where I am right now, I currently can't find any higher risers. So what I've done is I found a couple sets I've got here and just decided to double them up. And so taking my risers, and this is a system that's just for demonstration. It would never be out in the field. But for this scenario, we can go ahead and double up some parts and take advantage of what we have on hand, and instead of scrambling to make sure that we try to fulfill needs that might take us months when we just need the solution as quickly as we can get it. And so in this case, I've brought in these risers. We would also need 3.5 millimeter screws here in order to make sure that we can put our battery board down onto the enclosure here. And again, generally for maybe not for all models, but for most of them we found we've got screw holes that are perfectly lined up for that scenario. And so now that we've got our risers, our next setup here for this particular breakout, we're looking for the P's. And so we see P1 through 4. And so I'm just going to find these P's. And again, these connectors do have grounding points. So if you were to use a metal riser, those would allow you to have a bit stronger grounding between the different planes. So I will just quickly screw these together. Just finger screw it. It's plastic. It will strip it if you tighten it too much. So we just want to make sure we use very little torque here. And again, it's another reason why the brass solutions are a bit more reliable, because you can get some non-slip washers or other scenarios that will make sure they won't rattle apart when they're being shipped. I don't have a box here that I've drilled out and made fresh, so I am going to repurpose one of our other boxes that we've already done. And so this is similar to what we saw before with the power button. This is a two-plug scenario. This is only going to be connecting to one of our outputs on our I/O board, because these two are SDI 12 and they work in a serial bus, so they just need the one. We have here on this side, on the closest side, we've got our switch, and then we've got our solar. And as I mentioned before, we've got it to where ground is top and plus is at the bottom. And so I'll take out the other parts here that I put together. And we're just going to get this slotted in. One of the tricky bits, if you were to put your power button on the side that we chose here, we have left a bit of space with some of the ICs on the board to make sure that they don't bump into kind of some of the larger switches. So generally, I do recommend that you use this side, but you got to make sure that it's not going to bump into the battery part or the battery holder or the any of your wiring here, and it's risen above where it can have any influence on the actual board. And so it'd probably be hard to see on the video, but there are little risers inside of here. And so now all I'm doing is just lining things up, making sure everything is in place. In this case, everything kind of like feels as though it's exactly where it's supposed to be. And so now I'll take my 4 screws And in this case, for this particular board, what we're screwing down to, is fairly easy to identify because we don't actually have any grounding around that. I did make a mistake. Generally, when you get to this stage and you find yourself without having plugged these in, you've gone too far too quickly. It's better to have these plugged in first. There are ways you can dig in there and redo it, but generally it's just easier to have it all set up before you get in there. And so that sets us back a little bit, but just have to refit it, make sure it's nice and snug in there. Make sure you have a screwdriver that has a decent magnet because slippage like that happens quite often, at least for me. Okay, so now everything's down, everything's secured. This guy's going nowhere. So all 4 screws are ready. So the next phase is the fun part. You're just loading your batteries, and so you can see it's marked plus and minus and so forth. Generally we do plus on the sides at the top, and minus in the middle. And one kind of pro tip is that when we are out in the field and we are testing these, we really are just looking for a grounding point. And so when you've got your IO shield on, generally when you're out in the field, you've got it set up like this, and we just want to check our battery voltage. We just need to find a grounding point. And so anywhere where there's a good ground on the device, and that could be our SD card here. We can take this, and the battery that's next to the power pin or the power button, we can go ahead, and that is going to be where we're going to read our 12 volts. And so in this case, we can see we're at 12.51 volts. That's pretty close to being at full capacity for this type of battery. And so now that we've got that in place, if you do decide to put in an SD card, you're going to want to go ahead and do that now before it goes in the box. And then you're just going to take your risers, slightly smaller risers, the same ones. The lid generally will fit quite big risers on there. And then we just go ahead and screw those in place. And generally you want to use all 4, but for now I'm just going to use the 2 because that's what I have in front of me. These are older ones, or for another application that's too small for this. And now we're ready to go with it. Now, if we were to leverage the expansion part where we want to put in the 3G, 4G radios, or the cellular radios rather, we can do so at this point. Easy to pop these in place. They do come with little tiny screws, and you just place those down. Get your SIM card in there. In this case, we're going to use this for a all-weather system that we use on I2C, or excuse me, on SDI12. So we're going to connect up to this pin. But in this configuration, once the software is flashed, this will be ready for the field. Now, of course, that doesn't mean that this particular product would be ready for the field, given that we've kind of cut a number of corners here. But it'd be ready for your bench and for testing and for trying solutions that you want to try at your office or at your house. And so now everything's ready to go. It is using our Hyphen Connect solutions and what will be our Hyphen OS. And so once everything connects, you can see here we've got the 5-volt power that lights up. And then this one probably isn't flashed for anything, but you would see it connect. And you've got a kind of breathing blue light that it shows you that it's online and it's active and ready to go. But I thank you for spending the time with me to walk through how Similie assembles our Hyphen line of IoT systems, our field systems. We've been doing this for years in Timor-Leste, and we now have all our designs and some of our solutions that we've been working on for a number of years out and available for end users to anybody in the community to leverage and build their own kind of solutions and packages around. But if you have any questions, leave a comment or reach out to us at similie.com, and we're always excited to meet other people in the community that are interested in this sort of innovation. Thank you.